Welcome to our tech news. Let's talk about how AI can unravel the mask image. Some people feel that AI is just like a magician doing magic. Today I want to reveal the mysterious view of this AI to everyone so that we can understand how the magic algorithm is done. First, we will look at the mask on the text, and then we will look at using AI algorithm to restore the masking image of the human face, and how to turn low resolution image into high resolution image using special AI algorithm. We know that a picture is actually comprised of many small dots, whether it is on computer screen or a picture on a paper. The representation of an image is identical to our eyes. So if a picture has more small dots in it, the picture will look much clearer. On the other hand, the process of masking an image is actually reducing the number of small dots on the picture. For example, for just one color gray, there are many different kinds of grays. After the masking process, the number of type of gray become less and maybe just 2 or 3. So if you are talking about the text, as the number of the type of color become less and less, it becomes difficult to differentiate the image in detail, so we cannot recognize the character on the text anymore. A person called Malama, who studied AI and invented the use of linear box filters, and proposed an AI algorithm called DPix, or like the depixelization process. Unlike a three-dimensional human face, his algorithm focuses on specializing on linear two-dimensional image. So he developed a way of restoring the masked letter from unknown text. So he analyzed every letter from the alphabet A to Z and number 0 to 9 by dividing each letter into small blocks. Basically, he put all alphabet A to Z letters, numbers, and symbols in one image as shown on the slide. Then each letter is further divided into blocks and translate each block into numerical value and then save into a database. Later, he made two datasets. One dataset is holding the analysis of each letter after breaking it into blocks. Another dataset is to analyze two letters as a group. The reason for analyzing multiple letters at one time is because, depending on the font, some letters will occupy and share the same block when the text is masked. So you may also have a small letter L and O, and they may look like a small letter B or D. So in order to have a better recognition from the masked letter, we also need to examine the space between each letter, so the analysis of a group of two letters is a good idea. So now the database contains a large number of pixelated alphabet with blocks information. So far it looks like a library of pieces of block information. We can now input the unknown text that we want to decipher. First, we will digitize the unknown letter and then analyze it by looking at each block and compare against with known blocks in the database. During the matching process, we set some assumptions, calculate the distance between some pixel blocks, and then compare the pair block around other blocks. So now the AI algorithm is trying to decide whether the smallest block is black or white. So with both assumptions and decisions, the program determines the final look. Finally, each block is matched from the database according to the assumption and calculation. So the result is a kind of approximation rather than a guarantee. As you can see from the slide, the algorithm predicts how the letters may look like, and the final result may be recognizable to our human eyes. Okay, let's now demonstrate how to digitize a letter into numerical value. Please note that this is just for illustration purpose. We just want to let you know how a digitization process may work. But this is not a method used by melanoma researcher since it involves more intense calculation behind the scene. Okay, so let me start with 9 blocks. I'm going to write letter A in the box, and I'm going to transfer the information on each block into a numerical value. So the first block, I don't see any part of the letter A, so I will put 0. And the second block, we see that there's a part of A, so I put 1. So the third block, we don't see anything, I put 0. Then the fourth block, we see some part of the A. Then the middle center block definitely does 1. And the sixth block, we see 1, right? So on the seventh block, we have 1, and this is 0, right? We don't see part of letter A. So at this point, we have some kind of values, and we can save this as either in a same field like 0, 1, 0, 1, 1, 1, right? 1, 1, 1, and 1, 0, 1, 1, 0, 1. So we can save this field into the database. So for example, if we have an unknown mask letter, such as something like this, with a different gray color, then we can digitize as 0, 1, right? 0, right? 1 as a present with a block, right? Is filled. So, and this corner is empty, right? And this is all filled, 1, 1, 1, right? And the bottom row will be filled, not filled, filled, right? So we have 1, 0, 1, 1, 0, 1. So by digitize the unknown mask letter into numerical value, we can go to the input to the database and search for it. So in this case, there will be a match. So if that's a match, that means the input, I will be having a high confidence on giving this input should be an A, letter A. So how do we restore the blurry face picture through the AI algorithm? Because our face is three-dimensional, the linear algorithm we just mentioned earlier won't work well. Let's go back to the idea of an image is comprised of many small dots. When the picture is blurry, this means that there are not many details on the image itself. So logically, or the old thinking, is try to add some details to the image in order to restore the picture. It is difficult to develop an algorithm to predict or determine whether or not to add small dots in order to fix the detail on the image. The process is often unpredictable and unreliable, so this method does not work well. A group of researchers at Duke University has developed a method called PAUSE that takes advantage of amazing advances made in machine learning in recent years to solve this problem in a completely different way. His method is very simple. In fact, it is compared to a smaller feature of a known face with another unknown small feature to synthesize the detail block by block. So at the beginning, they input the unknown faces of thousands of people into the database with high-resolution pictures. And on each face pictures, the program divided them into smaller features, and then recorded each smaller feature at a low resolution. So when everything is ready, we get a low resolution and mask face picture, and try to restore the face piece by piece. So first we divide the unknown mask face picture into a small feature, and then find the same small feature in the database with a low resolution piece. When there's a match at a low resolution level from the database, we obtain the high resolution and add to the unknown face as a way of reconstructing the detail. Now using the machine learning, we can quickly do comparison and match process at higher speed. After thousands of small features being restoring block by block, small feature by small features, the program begins to construct the entire face. So after many adjustments and corrections and with the help of machine learning, the PAUSE algorithm has developed and solved this problem and give a high resolution face picture from the masked low resolution face picture. In addition to restoring the original picture, the PAUSE algorithm can be also used in different fields like microscope, astronomy, satellite imagery, and medical applications. Okay, that's it for tech news. Thank you for watching. I hope you enjoyed the video. If you like the video, please subscribe and support our channel. I will see you next time. Goodbye.
At Uniting Digital, we offer a platform for digital talents to share their expertise by becoming a contributor. We also offer digital transformation consulting services in digital strategy, technology roadmap, implementation plan, and orchestrating transformation.